Hi everyone, my name is Umang and my co-presenter name is Dhishankar. In this presentation, we'll try to identify emerging 5G use cases and its impact on edge and core storage. So this slide talks about the evolution and deployments of 5G from pre-5G era to early 5G and to current full 5G. If you see the right side of the diagram, we are currently in full 5G categorized as release 15. Deployment of full 5G release 15 will enable new applications and new use cases. One of biggest advancement in full 5G is support for ultra reliable low latency communication. We call it as URLLC. This feature will cater to multiple advanced services for latency zero sensitive connected devices. We are talking about 1 millisecond latency here. Example of such use cases are factory automation, autonomous driving, smart grid, robotic surgeries. One thing is sure that 5G will be driving new digital revolution in terms of speed, scale, and stability. If you compare key statistics between 4G and 5G, we are talking about peak data rate that is 100 times faster, latency which is 50 times lesser, and connection density which is 50 times more than 4G. There is a record that 90% of data in world has been created in last 2 years. And as per the IDC estimation, global volume of zettabytes data generated annually is projected to triple between 2020 and 2025. And 5G is going to be the biggest contributor for that. 5G will support wide variety of new use cases. One thing that will be common among all these emerging use cases will be that all of them require ultra low latency, high storage capacity, and high computing power. So one of the top 5G use case is connected cars and autonomous driving. It is also categorized by ultra low latency, high storage capacity, and high computing power. With increase in compute, storage, and network capability, many vehicles will look like a mini data centers on wheel. All of data generated here will be transmitted over 5G network. Some cars could potentially generate a data of 5 terabyte to 20 terabyte per day. Next use case that comes in this table is about video surveillance. This video surveillance is about transmission, storing, and processing of high quality video data, whether it is deployed in homes, enterprise stadiums, or public transport in the smart city. Estimation is that ultra high definition 4K surveillance video could generate about 7 gigabytes of data per hour. And again, this will needs to be transmitted over 5G. The third use case is about sensors that will be running in the smart factories or in smart grid. Say, assuming that you have a 10,000 sensors and each sensor sending 1 kilobyte of reading per second, it translates to 3.6 terabyte per hour over 5G. Similar data explosion will be seen in all other 5G use cases, whether it is telemedicine, online gaming, or in factory automation. The role of 5G here will be to facilitate on offloading data to local edge site for storage and processing. So so in this diagram, right, what is expected to see with 5G is that data goes from end user enterprise device to perhaps an enterprise campus edge before making it way to telco edge cloud and then off to a centralized cloud. For consumer, out and about data would go from mobile phone to telco edge and then perhaps to a centralized cloud. Now the key question is what happens to the data explosion seen in edge because of 5G. We are talking about billion devices connected through wired and wireless in 5G infrastructure, bringing explosion of data at the edge. One of the things happening to deal with this data is to bring cloud-like computing capability at the edge. The cloud native architecture is going to become a de facto way how edge is designed. All the deployment services architecture at the edge will be influenced by cloud native way of designing. There will be more emphasis on designing microservices based architecture instead of monolithic architecture. Also at the edge, right, there is a growing appreciation that an edge network should be designed as an autonomous and intelligent system. Concept of autonomous network mandates distributed intelligence and AI MML capability across entire network in order to drive real-time insight and responsive network adaptation. It is too expensive to move that large data to cloud to generate insight. Additional AI ML techniques are also expected to be critical in offline network analytics, capacity planning, network service orchestration, and subscriber management, as well as for training bulk of AI ML services deployed at the edge client. Now, my co-speaker Dhishankar will take forward the presentation from here. Over to you, Dee.
Yeah, thank you, Umang. Can you hear me okay?
Yes.
Okay. Okay, so, from this section onwards, I'll take over the presentation. So like Umang mentioned before, right? So we are expecting this huge data explosion at edge, right? And 5G is basically going to be the game changer for that, right? Some of the stats that Umang gave, right? By 2025, we are expecting that each of the person connected to the internet will have one data interaction every 18 seconds. So you can just imagine the amount of data that these edge devices will kind of start generating. The edge continues to still grow at an exponential rate, and some of these statistics Uma actually gave, like the video streaming part of it. So one aspect there that I would probably like to bring is that what you are seeing today is just just a little bit of the data that we expect, right? So imagine when the resolutions grow to 8K and beyond, right? This is absolutely going to explode, right? Some of the smart sensors part, which Umang talked about, which is generating about 3.6 terabytes per hour. This is gonna basically require more smart sensors to be deployed to really achieve that autonomous factory kind of an environment. And with the millisecond latencies, right, this is possible, and this is all because 5G is going to start providing you those ultra reliable low latency deployment models that is not possible today. So what do we do with all this data at the edge, right? Some of the things that Uma actually alluded to, right? So you would have to provide real-time data insights to all of these data, right? Because now imagine an user with a mobile phone who is able to download and upload gigabytes of like for example a movie or something, right? within milliseconds, right, on his device. And like that, you have other use cases where he would probably like to take action based on real time insights that the providers are able to give it to him, right? So with that said, right, Umang, can you go to the next slide? I think the importance here is that we feel that edge is going to become the new core, right? You need to left shift all of your core processing, data processing kind of capabilities to the edge itself, because what is guaranteed is almost 75% of the enterprise generated data would be created and processed at the edge. And this is what Gartner is saying, right? And this will be all outside of a traditional data center or a cloud, right? So as you can see, what that would mean is it is going to increase your data set, right? The working data set that you will have to deal with is going to be huge. And that is where you need to provide real time analysis and actionable intelligence to the end user, by working on these huge data sets. And you would also need to groom the data at the edge itself, and be basically be ready to provide this actionable intelligence based on real time feedback from the user, right? And this is also kind of explaining the training of the AI and ML modules that you would probably have to deploy at the edge itself, right? So let's look at this in a little bit more detail. Umang, can you go to the next slide? So this is, basically in a nutshell, what we envision the overall, how it will work, right? So you have all your edge devices, the connected cars, the streaming, surveillance cameras, the connected devices, the IoT devices. All of these, start generating the huge data, which of course via the 5G, lands up on your edge nodes, right? So you categorize the data into streams. You also still have to handle your traditional object and file based data. And what you would probably now need to do is you need to process this data and groom this data at the edge itself, right? So you need to basically be able to have the core data center like processing available at the edge itself, right? This is where you will start applying your analytics and big data and the AI ML stuff, and basically groom the data, and also provide actionable intelligence to the end devices, right? So what this means also is that you actually now know what data is important to you, and what data you can actually discard, or move to your secondary storage, or where you have low cost storage capacity, right? That also means that the eventual data that you are sending off to your core data centers or cloud, right, is going to be much lower than today what we have, right? Today bulk of your data is actually transferred to your core data center for processing, and bringing out these actionable intelligence and all that, and shipping it back to the end devices, right? And that means that you need to have more storages at the core, for long term use. And once the data is identified, what is useful, the rest of the data is kind of discarded. This now you can take action at the edge itself, right? There is a possibility that using these analytic models and all that, you are actually able to deduce what data is important and what is not, right? You will see some of the new tools like lambda kind of functions, then some of the Kafka kind of architecture coming in, where you can apply that both to your traditional data sources like objects and files, and you can also apply that to your stream kind of a data object, and basically take actionable intelligence on that data, right? So this is what we feel that eventually each data center is the edge data centers are going to look like. You need to be able to provide the cloud native kind of behavior at the edge itself, and all the storage vendors have to start gearing up to basically provide that kind of a capability at the edge itself. Okay, let's move to the next slide, Uma. So what does that mean, right? So this for traditional storage, right, that means that you're basically bringing in the enterprise class processing and action at the edge itself, right? Some of the ability to work with these large data sets at the edge itself and apply the AI/ML model on the raw 5G data, the rich set of data services that you need to now provide at the edge itself, right? Because you need to provide these actionable insights much faster to the end user rather than basically waiting for the turnaround time to go back to the core storage and come back, right? You also need to think about the faster storage interfaces. Technologies like NVMe are going to become basically table stakes, right? You can no longer think of taking time in order to cater to those ultra low latency 1 millisecond kind of demands, right? So NVMe and some of those technologies are going to become table stakes, right? And that would also mean that you are basically providing the lower cost of ownership and also customized offerings for the different kind of data. Now each of these, like we showed the use cases, right, are unique data and different kind of data, right? So you need to provide customized offerings for those, right? I think Umang also alluded to this. So you need to bring up, simplicity and agility of the like the public cloud that you have today on these H-prem nodes, on-prem edge nodes, right? So we have to better manage the data. Some of the things that we talked about in the previous slide, that how to decide what is important, how to decide what goes to your secondary storage, what to discard, moving data back and forth, right? So those all become very important when you're trying to provide this millisecond latency response times, right? I also kind of pointed some of these out in the last slide. The streaming tools like the AWS Lambda, like the Azure and Google functions that you have, the Knative and the Flink from Apache. You will see that some more and more some of these will start getting deployed at the edge itself, and this will help us provide the kind of response and the analytics that we would like to be provided to the end users, right? So I think that's pretty much what we wanted to cover. I think this is probably our last slide, Umang. So this is the references and all that. I would definitely like to take this opportunity to thank SNIA for this great platform. I think we have been presenting at SNIA for some time, and every time it really gives us immense pleasure and a lot of learning opportunities that we see here. Umang, you want to add anything to that?
Yeah, I share the same sentiment. I think very nice opportunities given by SNEA to present in this forum. So thanks again.
Okay, I think with that, we have come to the end. I think we are almost out of time, so we're going to close the presentation. Thank you again.